You can fry an egg on a sidewalk at 130 degrees, but your brain begins to cook inside your skull at just 104. That razor-thin margin is the difference between life and a catastrophic internal meltdown. Our bodies are marvels of balance, constantly fighting to maintain a core temperature around a precise 98.6 degrees Fahrenheit through a process called homeostasis. Think of it as a biological tightrope walk. The ringmaster of this entire operation is a tiny, powerful region deep in your brain called the hypothalamus. It's your internal thermostat, constantly sampling your blood temperature, vigilant for the slightest change. Even when you're perfectly still, your body is a furnace. Every metabolic process, from digesting food to thinking a thought, generates heat. Your hypothalamus detects this rising internal heat and knows it's time to act before that tightrope walker stumbles. It's a silent, constant battle against your own internal fire, a battle you don't even know you're fighting until the system begins to fail. So how does the hypothalamus fight back? It initiates a brilliant cooling sequence. First, it triggers vasodilation. That's a fancy term for telling the blood vessels near the surface of your skin to widen, to open up. This transforms your skin into a high-efficiency radiator. Your heart gets the signal too. It increases its cardiac output, pumping more vigorously. Hot blood from your core is now rushed to this expanded network of vessels just beneath your skin, where the heat can dissipate into the cooler, outside air. It's an elegant engineering solution. Use the body's own plumbing to carry heat from the vital, sensitive organs in your core to the one organ that's designed for contact with the outside world, your skin. In a perfect world, this system, combined with the evaporative cooling of sweat, keeps that internal thermostat perfectly dialed in. But we don't live in a perfect world. The system has critical vulnerabilities. The first major failure point arrives in the form of two enemies: humidity and dehydration. Let's start with humidity. Your body's primary cooling tool is sweat. But sweat doesn't cool you just by being on your skin. It cools you when it evaporates, carrying heat away with it. When the air is thick with humidity, it's already saturated with water vapor. Your sweat has nowhere to go. It can't evaporate. This is the wet bulb effect. The sweat just beads up and drips off, its cooling potential utterly wasted. You're soaked, yet you're only getting hotter. Then comes dehydration. As you sweat, you lose fluid. If you don't replace it, your blood volume drops. Your blood gets thicker, harder to pump. This puts immense strain on your heart, which is already working overtime. With less water in the system, your body can't even produce enough sweat to begin with. The cooling system is now doubly compromised, fighting a losing battle against an enemy it can no longer effectively counter. This brings us to the crisis point. As your core temperature climbs and breaches the critical threshold of 104 degrees Fahrenheit, or 40 Celsius, the cascade of failures begins. Your circulatory system, which has been fighting so hard, is now completely overwhelmed. The heart can't pump the sludgy, low-volume blood fast enough. Blood pressure plummets. And here, a terrifying and often misunderstood event occurs. You stop sweating. This isn't a conscious decision or the body trying to conserve water. It's a total system failure. The sweat glands shut down because the collapsed circulatory system can no longer supply them with the fluid they need to function. The final and most effective cooling mechanism has just gone offline. You are now trapped inside a body that is not only generating heat, but has lost its ability to release it. The internal furnace is raging, and all the windows have been sealed shut. Once your cooling system collapses, the trapped heat begins infiltrating your cells, triggering the first stages of microscopic destruction. This process is called denaturation, and it's where the cascade of heat stroke begins. Think of a protein not just as a substance, but as an incredibly complex, microscopic machine, folded into a precise shape like a coiled spring. Its function depends entirely on that shape. Heat introduces violent energy, causing this spring to vibrate uncontrollably. The delicate chemical bonds holding its coils in place, the very architecture of life, begin to snap. The spring doesn't just uncoil, it's permanently warped and broken. When this happens to billions of proteins inside your cells, from your muscles to your organs, those cells stop working. They lose their structural integrity and their ability to perform their essential jobs. It is, quite literally, the beginning of your body cooking from the inside out. Now imagine this cellular breakdown happening along the most critical barrier in your body, the lining of your gut. This intestinal wall is meant to be a fortress, with cells locked together by tight junctions, carefully regulating what enters your bloodstream. But under intense heat stress, those junctions fail. The proteins holding them together denature. Cracks begin to form in the fortress wall. This is what doctors call leaky gut, and it allows an invasion from within. Your gut is home to trillions of bacteria, and when they die, they release toxic components called endotoxins. With the barrier breached, these toxins flood directly into your bloodstream, triggering a massive systemic inflammatory response called endotoxemia. Your body's own immune system goes into overdrive, attacking everything, further damaging your organs. The threat is no longer just external heat, it's an internal toxic assault. While this toxic, inflammatory storm rages through your bloodstream, your command center, the brain, is facing its own unique crisis. Elevated body temperature causes the brain itself to swell, a condition called cerebral edema. But unlike a muscle in your arm that has room to expand, the brain is trapped inside the unyielding bone of the skull. This protective case now becomes a torture chamber. As the brain tissue swells, it has nowhere to go. It presses against the hard inner surface of the skull, increasing intracranial pressure catastrophically. This pressure squeezes blood vessels, starving brain cells of oxygen, and directly crushes neural tissue. The results are terrifying and swift. Profound confusion, disorientation, seizures, and eventually a complete neurological shutdown. The brain, the very seat of consciousness, is being physically compressed and suffocated into silence. With the brain offline and the body ravaged by inflammation and cellular damage, the final stage begins: multi-organ failure. The liver, the kidneys, the heart, they all begin to shut down under the immense strain. At this point, there is only one intervention that matters, and it must be brutally fast: rapid cooling. This isn't about sipping cool water. It's about aggressive, immediate temperature reduction. Medical professionals talk about the golden hour, the critical window after the onset of severe symptoms. The gold standard treatment is immersion in ice water, a shocking but life-saving procedure designed to pull the heat out of the body's core as quickly as humanly possible. Every minute of delay allows more proteins to break, more toxins to leak, and more brain cells to die. It is a desperate race against the clock, fighting to stop the boil before everything is lost. Have you ever pushed your limits in the heat and felt that warning sign? Tell me below and subscribe for more survival science.